quotient rule. If we had a rule for when we multiply two functions, there's got to be a rule for when we divide. And if multiplying was complicated, then dividing probably should be complicated too. And it is. So again, we're going to color code because we're going to talk this through. You've got a function on the top and a function on the bottom, which we will refer to the top function and the bottom function. With the quotient rule, it's sort of similar to the product rule where you keep something the same derivative of the other one. But now it is important which one you keep the same first. So we need to keep the bottom the same, multiply it by the derivative of the top, then keep the top the same and multiply by the derivative of the bottom. And with the product you added, with the quotient you subtract. Which fits with some other things that you did, like if you think about your log laws, the product rule for log laws was adding, the quotient rule for log laws was subtracting. So we've got some sort of similarity happening there. And then it's divided by the bottom square. And in other notation, if you wrote it as just a u divided by just a v, we could color code the same way. We keep the bottom the same, multiply by the derivative of the top, then subtract, keep the top the same, multiply by the derivative of the bottom over the bottom squared. And then we can have fun. So, how do you know when to use the quotient rule? Well, if you have a fraction and the fraction has x's in your numerator and x's in your denominator. You wouldn't need to use it if you had just a number in your denominator, because then it's just like a constant. But in this case, we have x cubed as our top function and 3x minus 7 as our bottom function. So our derivative, we keep the bottom the same and then do the derivative of the top. And the top is just the 3 comes out in front, subtract 1 from these both. Subtract, keep the top the same, and multiply by the derivative of the bottom. Well, the derivative of 3x is 3, the derivative of 7 is 0, so that's just 3, all over 3x minus 7 squared. Now, these questions in particular is probably, out of your textbooks, the best ones for practicing your algebra. They practice a lot of good factoring skills, and the way the final answer is written in your textbook, always try, after you've done this, to see if you can simplify it to make it look like the back of the textbook. One of the things the textbook likes to do is it likes to factor to see if things cancel out. And I want to show you a factoring skill in this one that sometimes you don't see as often, okay? Most typically what students will do with the numerator at this point is they'll say, oh, if I want to simplify things, I should multiply everything out and combine my like terms. And that's exactly what you would have done in grade 9, grade 10, grade 11 math, even grade 12 math. So it is a strategy that works. But if we can see factoring early, we can sometimes make our algebra easier for us. So what I mean by factoring earlier is on the top here, the dy dx. On the top of this fraction, we right now basically have two things, two terms, subtracted. There's this term here minus this term here. We consider something a term when it's grouped together with multiplication, even though this one has like a binomial in it. This is like one thing minus one. And if we can factor something common out of those two things, we can make our algebra even easier. So now I look and I say, is there something common in here? This 3x minus 7 is considered one thing that's grouped together. So the only way I could factor that out is if I had a 3x minus 7 on this side. But I do have a 3 and a 3, and I have an x squared and an x cubed. So can you see that these have a 3x squared in common? What would happen if I took the 3x squared out of the first term that I underlined in green? Can you see that you would be left with 3x minus 7? And what would happen if I took a 3x squared out of the second one? I would just be left with an x. I still have the 3x minus 7 squared on the bottom. So this concept of recognizing a common factor before you multiply it out can make your simplification easier. So at this moment, now inside these brackets, I'm like, oh, I have some like terms, 3x minus x, that'll be 2x minus 7. And the reason we want to write things in factored form is to see if anything simplifies further. In this case, you would need a 3x minus 7 factor to cancel out, right? We can't cancel out part of a binomial. If it's adding and subtracting, that's grouped together. I can't cancel out this 3x with this 3x, because this 3x is connected to the minus 7 as a single factor. So we can only simplify when we have completely identical factors, not just part of one and part of another. And adding and subtracting always groups something together as one of our factors. So at this point, we would know, okay, it doesn't simplify any further. And we have our final answer in factored form. So you might find that your textbook writes your final answer in factored form, or maybe it had the answer with this distributed in the end, 6x cubed minus 21x squared. But I find that this method of simplifying, recognizing something in common earlier, will often save you time rather than multiplying it out. Multiplying it out is not wrong. We could have distributed this, combined our like terms, then found out there was a 3x squared in common. And in this case, it might be very similar in the amount of work. But having this other skill is going to be helpful. So, we notice we have a quotient rule because we're dividing. There's x's on the top and x's on the bottom. Okay? One of the things that I would recommend that you do if you're ever having to do something where you're like, you take the bus home, or someone's driving you somewhere and you're not actually having a conversation, go through your head and say to yourself, do I know the power rule? Bring the number in front, subtract 1 from the next one. Do I know my product rule? Can I say it out? Keep one the same, multiply by the derivative of the second one, keep the second one the same, multiply by the derivative of the first one. So walk through those rules for you, because you will need them to be readily available while you do questions. So same thing with the quotient rule. Walk through the rules. Say, I keep the bottom the same. Multiply by the derivative of the top. That'll be 2x, 5x will just be 5, and the 3 is 0. subtract, keeps the top the same. Multiplied by the derivative of the bottom over the bottom square. This one we'll just leave unsimplified. Looking at it though, I did a quick look. Was there, in this term and this term, was there a common factor? No. The best we could do in this one is actually multiply everything out, combine like terms. But if nothing factors out early, probably nothing will factor out later as well. So a quick reminder of what are we doing when we're finding a derivative? Because we would get into these rules and we get sort of fixated on them and learning how to do them, but then we forget what a derivative actually is. And a derivative, again, it's just boring. It's just finding the slope of a tangent line at any point on your graph. So here you have a graph, x cubed over x squared plus 1. And if we found the derivative of that graph, we would find an equation that would give us all the slopes of all the tangents on that graph, wherever we want it. We're interested in finding the slope of the tangent at -1. So my derivative, that finds the equation for all of the slopes. It doesn't find the equation of the tangent. It finds the equation of all of the slopes of all of the tangents. And again, here we would have to use our quotient rule, keep the bottom the same. Derivative of the top minus keep the top the same, derivative of the bottom over the bottom square. I'm going to just do the mental math for each bracket separately. If I plug in -1.
X squared plus 1 shouldn't be the 2x on x squared plus, no, at the top. No, the x squared plus,
This one here?
no, yes.
Okay.
So shouldn't be the 2x.
No, because the first step is keep the bottom the same. So the bottom is x squared plus 1.
Oh, yes.
We keep it the same.
Yes, yes. Sorry.
And actually, it's interesting in calculus. A lot of steps in calculus is keeping something the same. And it's amazing how difficult that is. Because in math, you want to do something. And if the first step is keep something the same, you feel like you're holding me back. I want to do something. I want to change something. And then that causes you problems. Because a lot of it is keeping something the same. Oh, wait till we get to the derivative of e, the number e to the x. It's like the worst derivative and the best derivative all at the same. Yeah, I have to wait until we get it. But, okay, so we're good?
Yes.
Okay. So now what we're going to do is I'm just going to plug in -1 into each of these. Can you see the first bracket's going to be 2? -1 in the second one, it's going to be 3. Minus -1 cubed is -1. That'll be -2. And on the bottom will be 2 squared. So just did the mental math for each one, and now I think I'm pretty comfortable I could do the rest of it. It's going to be 6 minus 2 on the top, which is 4. 4 on the bottom, 4 divided by 4 equals 1. sometimes you also don't realize how far your mathematical skills have improved. Do you know how painful this question would have been plugging in -1 for grade 9? It would have been like a 10-minute question we would have to go through in grade 9. And now you're able to do that mental math and you're like, yeah, straightforward. Make sure that you realize how far you've come in your mathematics in high school. Like, it is amazing. It really is. The problem with math sometimes, in my opinion, is we always do the next hard thing. So you're always like, oh, this is hard now. I'm not good at this. And then the next day, I'll introduce, oh, now this is hard, and I'm not good at this. But you never really get the time to go back and say, hey, do you know how good you actually are in a lot of things? Okay, so we found the slope. The slope is 1. And then it says, find the equation of the tangent line. So to find, this is grade 10 math, we'll remind ourselves, to find an equation of a line, you need 2 things. The first thing you need is the slope. The second thing you need is a point. We know the slope because the slope comes from our derivative. We don't know a point yet, but we know that we want to find it when x is -1. But in order to have a point, we would also need the y-coordinate. So we have to ask ourselves, well, if I know an x-coordinate, can I find a y-coordinate? Yes. I can find that y-coordinate right here by just going to my original equation and say, well, if I plug in -1 for x, right? There's my original equation. I plug in -1, and I get -1. And if you have an equation and a point, that is enough information to find your equation of your line. So I'm going to remind you of 2 things from grade 10. Most students remember this best. Equation of a line, the first thing you think of is y equals mx plus b. Perfect. If you think of that, then you can use that. What do we know? We know the slope is 1. And we know it passes through when x is -1, y is -1/2. So using this information, you can add 1 to both sides and find out that b is 1/2. So now you have enough information. The slope is 1. Your b value is 1/2. And you get y equals x plus 1/2. In grade 10, you also learned a point-slope formula. So I'll show it to you. Just do you remember seeing that formula in grade 10? And most people are like, not as, like y equals mx plus b was good, right? This one, the way the point-slope formula works is it's got a spot for your slope and a spot for your point. In fact, a lot of grade 10 students like it that way because, oh, I just plug things in the right spot and then I'm fine. So I could solve this by saying my y value was -1/2, my slope was 1, my x value is -1. Subtract that 1/2 on both sides, and you get the same thing. Just different forms. Technically, do you remember your slope formula from grade 10? That slope is rise over run. Rise is your y values, your run is your x values. So this formula students remember. Y equals mx plus b, they remember. The point slope formula is just this formula rearranged. See the x2 and the y2, they just said, let's just make that x and y and just have one point. And then if we multiply both sides by the x minus x1, we would get this one. But I'm thinking, moving forward, based on your reactions to, yeah, I remember this completely, compared to y equals mx plus b. We're probably more comfortable with y equals mx plus b. Okay. On a test or on a quiz, if I want you to be able to do the manipulations to make it look like the back of the book, I will ask you to show that something. So I'll say, here's the original question. Show me that the derivative is equal to this. I'm basically giving you the answer. It's like a mini proof, if you remember trig identity proofs, where you have to show that one thing equals another thing. So now you just have to use your algebra skills, start with this, and we need to end with this. Well, if I want to show the derivative is equal to something, I'm going to need to start with my derivative. Well, how do I find the derivative of quotient rule? Keep the bottom the same. Multiply by the derivative of the top. Minus, keep the top the same. Multiply by the derivative of the bottom over the bottom squared. So this would be step one. And obviously it doesn't match with what the show that is, but I do take some time, just like in an identity, to sort of look at what I want it to look like and look at what I have to determine what might be the best thing to do next algebraically. So first thing I noticed was that my denominators are already the same. I have x plus 2 squared, x plus 2 squared. So that means all I need to do is manipulate my numerator here to try to make them the same. Doesn't look like I would do any kind of factoring. It looks like it's just multiplied and simplified. So then that sort of guides me as I think that would be the best choice. So now on the top, I'm going to multiply this out, giving me 2x squared minus 3x plus x minus 6. And this subtraction sign means that each of them will get subtracted. I would not multiply out the bottom because I need it to look like that in the end. And now when I combine all my like terms, I get x squared plus 4x minus 7. And as far as show that questions go and level of difficulty, this one was fairly straightforward. Okay. Part 2 to this question, find all the values of x where the derivative is undefined. Undefined, you are looking for the x values that make this not possible. So we have to go through. In our mathematics, we have learned a number of things that aren't possible throughout the years. The most common ones, can't divide by 0, can't take the square root of a negative, right? Those are your most common ones. You've learned some other ones, like sine x can't equal 5, can't be bigger than 1, because it's opposite over hypotenuse. That'll cause an error. You've learned maybe, not yet, but most of you have learned can't take the logarithm of a negative number. That's another thing that's not allowed. So we have some of these things that are allowed and some that are not allowed. We look at the situation. The only thing I see here is dividing. So when is it undefined? let's say dy dx is undefined when x is equal to -2. Because that would cause us to divide by 0. So, again, this is really important for us to practice our algebra skills. I will give you time to work on these. Take out your textbook or take out your textbook on your phone